our last class we have learned the most important fact about why we need electronic instruments. Okay? The fact is that we need high internal resistance for voltmeters and amplification if we want to measure small voltages or currents. If you recall, a couple of weeks back we were studying op amps, and there we studied a lot of amplifiers, right? And what does an amplifier do? It takes a voltage, small voltage, amplifies it. So, those amplifiers fulfill definitely one of the two requirements, which is amplification of small quantity, and then we can measure it using a normal voltmeter, classical electromechanical voltmeter, once it is amplified. This amplifier should also satisfy the requirement about the impedance of the measuring instrument. So, let me draw the scheme of measurement in general. So, say this is a circuit and we have 2 points, 2 terminals where we want to measure a voltage. So, this is a circuit being measured. So, you want to measure this voltage A B V A B. Instead of connecting an voltmeter directly like this, what we will do is this. We will first take an amplifier, so we will give this to the amplifier, and the output of the amplifier will be connected to a normal voltmeter. This can be a classical electromechanical voltmeter, okay? And this two together, the amplifier and the voltmeter, so this together is my measuring instrument or measuring unit. Or instrument, okay, which has an amplifier inside and this voltmeter. So, and as I was saying, do not ever think electronic instruments mean digital instruments. No, this instrument can be an analog PMMC instrument. Okay. So, this is a general scheme or structure of general scheme of measurement. Okay. Amplify and then measure. Now, this amplifier should amplify this voltage. Not only that, it should also ensure that less and less amount of current is drawn from this circuit. Okay. So, the amplifier is to draw minimum current, or if possible no current at all. Okay. So, that means the internal resistance of amplifier should be, how do we define it? We define it by this voltage VAB, okay, plus minus, call this current I, okay. Then we define it as VAB by I, as you know, and I tends to 0, tends to 0, therefore, this quantity tends to infinite. So, we want high internal impedance for the amplifier, that is what we need. Now, let us see whether the amplifiers that we have studied, inverting, non-inverting difference amplifiers, fulfill this requirement or not. So, let us take first an non-inverting amplifier. Non-inverting amplifier based voltage measurement. How does a non-inverting amplifier look? So, from the output of the op amp, we take a potential divider and a fraction of this voltage, output voltage, goes back to the input, negative input, and here we have the input. So, this is the amplifier block. This is plus here. So, this is the amplifier. And now we have a circuit which we want to probe, which we want to measure. So, this is, let this be a circuit. Which is say equivalent to this. Some voltage source, Thevenin voltage, Thevenin resistance. So, this is the equivalent circuit. So, this is this voltage, okay, call it A. So, we want to measure V A is equal to how much with respect to ground. So, what we will do? We will simply connect this like this, and here we will connect a voltmeter, normal voltmeter. Where should be the other terminal of the voltmeter be? This should be connected to the ground. When I draw anything like ground in such similar diagrams, it actually means that all these terminals are shorted. Okay, so that's what is important. So, all these terminals are actually shorted. If I do not want to draw this line, when I put the common symbol of ground, it means they are commonly connected. Okay. So, this is the scheme of measurement. Now, we know that if this voltage is R1 or call this R2, R1, okay, then we know that if this is VA, this voltage VO will be how much? VO will be amplified VA multiplied by 1 plus R2 by R1, which will be measured by this voltmeter. This is all we know. Now, let us take a okay. Now, important thing is that, so this is my measuring instrument. Okay, so now these two together is my measuring instrument. So, it should fulfill two requirements. Number one, amplification. Do we have amplification? Yes, there is an amplification. Okay. So, there is definitely an amplification. So, amplification achieved. Now, the second requirement is what? High internal impedance for this measuring instrument. This is a voltage measuring instrument, right. So, therefore, we need a high internal impedance. Now, how much is the internal impedance of this circuit? Ideally, theoretically, you know that this current here is 0. So, this current is 0, because no current can go inside the input terminal of an op amp theoretically. So, this current is therefore 0. So, this current is definitely also 0, right, theoretically. Practically very small. Now, if so, how much is the internal impedance of this circuit? It is this voltage, which is VA divided by 0. So, it is very high, infinite. Okay. So, also in internal resistance or impedance is tending to infinite, because this current is tending to 0. So, two requirements fulfilled. Great. Now, we will take a lot of examples. So, this what we are discussing now is not a new topic to understand, but this will take a lot of example to recapitulate and enhance and make our understanding solid. Okay. So, let us take a case when we do not need, say, amplification, and we only need high input resistance. So, this is a situation where the voltage to be measured is not small. So, we do not have to amplify it, but the circuit that we are probing has high resistance. So, the measuring instrument should also have very, very high internal resistance. So, this is a situation. So, what can we do? So, let us take this case. So, we do not need amplification, which will mean, now what was the amplification? Amplification was V amplification or gain, this was VO by VA, or you can call it V in. Okay. This was equal to 1 by 1 plus R2 by R1. Now, let us make it equal to 1. This is by choice, because we do not need to amplify it. So, how can we do that? So, that means we have to make this term equal to 0. Okay. So, implies R2 by R1 is equal to 0. This will imply what? Either I can take R2 equal to 0, right, or I can take R1 equal to very large, infinite, or both. I can take both. So, if so, then what I can do in this circuit, let me make R2 equal to 0. R2 equal to 0 means I short it, and R1 is infinite. So, this is infinite. Infinite means I simply open it, and then this becomes this. So, R1 equal to infinite, R2 equal to 0. Okay. So, then this is an amplifier where the gain is equal to 1. This circuit you probably have seen before. This is also called a buffer. This is called a buffer. A buffer means, what is a buffer? A buffer is a circuit that copies input voltage from the input to the output without changing. So, this value is copied here, same value we get. Okay. It copies the input to the output without changing. Okay. And it is not changing because no current is drawn. So, it should give high input, in this case infinite input resistance. So, no current is drawn. So, no voltage drop will occur here, but the same voltage will be replicated, duplicated at this point. Okay. So, this is an example of buffer. Now, let us take another example. Okay. So, let us just keep taking example. This is one example, this is another example. Let me take another example. Amplification, so, or voltage measurement with inverting amplifier. Okay. So, same thing, we have a circuit to probe, to measure call this voltage Vi. How much is Vi? Okay, which is same as this voltage when there is nothing connected here. And to measure it, we will first use a amplifier, this time an inverting amplifier. So, we give negative feedback. So, this is the input of the amplifier. This terminal you know is grounded. Ground means all this should be shorted, and call this R2, call this R1. So, this is the amplifier block. Now, this is the amplifier. To this amplifier, we will connect the voltmeter, and the input will be connected to this. Okay. So, this is the circuit, amplifier and voltmeter, same scheme. Okay. Now, let us ask how much is the amplification? Do we have any amplification? For this, we know it, this is equal to R2 by R1, we have derived it. Okay. You can go back and check, and if I do not need any amplification, I can make R2 equal to R1. Okay. So, if no amplification is required, take R2 equal to R1, then the gain will be 1. So, same voltage will come from here to here. You can in fact, in this circuit even attenuate the voltage, you can reduce the voltage if you want, okay, by taking R2 less than R1, that is also possible. And then internal impedance, how much? Impedance or resistance for this circuit. Okay. So, for that you have to calculate this current, call it I equal to how much? Okay. I is equal to how much, that is what you have to calculate. So, this will be equal to Vi by II, and this is easy because we know, we know that for this circuit virtual shorting happens. So, therefore, this 2 remains at same potential. So, this is 0 volt, therefore, this is also 0 volt. So, this is 0, this is at Vi. So, how much is the current? Vi by R1. So, this is equal to Vi divided by Vi by R1, this is equal to R1. So, this is the resistance. Now, if you want high internal resistance, what you have to do? You have to take a high value of R1. Okay. To have high internal resistance, we need high R1. Now, there is a nice observation that we can make here. You see, to have high internal resistance, we need high R1, okay, and to have high gain, if we want a high gain, we need high value of R2 by R1. Okay. So, here we need high R1, here we need high R2 by R1, which means low R1. So, you see this is a complementary requirement, right. So, we need a low R1 if we want high gain, and if we want high resistance, then we need high value of R1. So, this circuit therefore has a small problem. I mean, it is difficult to achieve both the goals, both the requirements together. Yeah, you may say that, okay, I will take both R1 high as well as I will take R2 very, very high. Okay? But then there will be other problems, the bandwidth, circuit response time, etc. There will be other problems, and you also know, standard very high resistances are not easy to achieve, calibrate, etc. There are other problems. Okay, so you cannot do that. You take R1 high and R2 high. That's not possible. Okay, that's difficult. So this has a small problem. Okay, nice thing to observe. And therefore, later we will see multi-stage amplification. Okay, we will study something like instrumentation amplifier. Let me just also tell you briefly what we can do. So, example, multi-stage amplification. What we will do is this, say okay, so this is the circuit, and what we will do, say we will take another amplifier at its output. This can be, you can choose it to be inverting, non-inverting, whatever you want. So, you can take another of this, connect them in cascade. So, this output goes to this input, right, and then here you can connect the voltmeter. So, what will be this voltage? Call this VO. What will, and call this VO prime. So, VO will be, VO prime multiplied by this R2 by R1, and which will be equal to this Vi multiplied by R2 by R1, one more R2 by R1, it will be squared. Okay. So, with this the gain increases. Okay. So, you can increase the gain in this way. You can take R1 to also to be high, where in that case this gain of one amplifier will be low, but you add two of them, it will be product of two. So, this way you can go on. Okay. Now, let us take another example or a question. Suppose we want to measure a voltage around say 10 millivolt, but we have a voltmeter with range 0 to 1 volt. Design a circuit that can do this. Design an electronic voltmeter. So, what will you do? So, this is a question which you may get in exam, in practice, in real life. Okay, that this is a voltage you want to measure, but the voltmeter is of this range. If I want to measure 10 millivolt with this voltmeter, so this voltmeter has 0 here, 1 volt here. So, 10 millivolt is somewhere here. If I want to measure this, so this is 10 millivolt. If I want to measure a small voltage, then the pointer will be somewhere here, and if I make a small mistake, or if the pointer is slightly away from its position due to friction or something, okay, then there will be a huge relative error, because a small error, a small change error out of a small deflection will give you large relative or percentage error. So, therefore, I cannot measure this voltage directly, I have to amplify it. So, what I will do? I will simply do this. So, I know this is V in, which is around 10 millivolt, and I have to amplify it to close to 1 volt. Okay. So, that means 100 times amplification. So, I need an amplifier which can amplify it 100 times. And now you choose which type of amplifier you will take, inverting, non-inverting. So, if I choose inverting one, then I also have to deal with how much resistance, internal resistance I want. Let us make it simple. So, I will just take this. So, this I will connect to this. So, what you are supposed to do if this question is given to you? You have to design this circuit, and design means you have to find out the values of all circuit parameters, like R2 should be how much, R1 should be how much. And here you have to connect the voltmeter, whose range is 0 to 1 volt. Okay. So, how much R2 will you take? How much R1 will you take? So, we know we need 100 time amplification, gain required is 100, but gain is given by 1 plus R2 by R1. So, we will take, so let us take R2 equal to 99 R1, and let us take R2 equals 99 kilo ohm, R1 equals 1 kilo ohm. Now, you could have also taken this as 1 ohm and 99 ohm, because it only tells you about the ratio of these two, does not tell you what should be the exact value of R1 and R2. Those considerations, I can give you more information so that you can choose these values, but right now I am not going into that much detail. This is just one example which will work based on these requirements specified in the question. Okay, done. Okay, let us take another example, or the question. Okay, let me just copy this. Suppose we want to measure a voltage around 10 millivolt, but we have a ammeter. With range 0 to 1, 0 to say 100 milliampere. Design an electronic voltmeter with using this ammeter. So, this time you have to make a voltmeter, electronic voltmeter using an ammeter. Okay. So, if we follow the previous scheme, copy, so let us see the solution. So, this is the voltage we want to measure, this is the amplifier that we have, but this time we do not have a voltmeter, we have an ammeter. Okay. Now, can we just connect an ammeter here? If we connect an ammeter here, then this voltage is 10 millivolt. We can choose proper value of R1 and R2, then we can tell this will be how much. This will be 1 plus R2 by R1 times 10 millivolt. This is known. So, this is a known quantity. Okay. This is known because I can choose the value of R2 and R1. So, this is a known quantity. Okay. So, I know this voltage, and the spec for the ammeter is 0 to 100 milliampere. Okay. So, if this voltage is known, can I tell how much current will flow through this? I cannot unless I know the internal resistance of the ammeter. Or in an opposite way, if I know how much current is flowing through this by observing the pointer position here, can I tell how much is the voltage here or how much is the voltage here? Unless I know the internal resistance, I cannot tell. No. Okay. So, this will not work. So, this will not work since internal resistance is not given. Internal resistance of ammeter is not given. Okay. So, based on the available data, I cannot use this circuit. So, this circuit will not work. Now, let us do a small trick. Let us play with a small trick. What I will do is this. So, this is the circuit, this is the amplifier, okay. And what I will do, I will connect the ammeter over here. Okay. So, I will connect the ammeter over here, and then I can say for what input how much current will go through it. Okay. Or if I know this current, I can tell you how much is this voltage, right. So, this circuit will work. Let us see how. Let us just solve this problem, then I think it will be clear. So, this circuit will work. Okay. So, you see that this point is at V in, right. This point is at V in, since this is an basically this is an non-inverting amplifier circuit. Okay. These two together you can think just one resistance. So, this is a non-inverting amplifier, and in a non-inverting amplifier virtual sorting works. We know that for a non-inverting amplifier virtual sorting works. So, using virtual sort, the notion of virtual sorting, I can say the potential over here will also be V in by virtue of virtual sorting. Okay. We know that, I am not going to repeat that now. So, by virtue of virtual sorting, this point will be at this potential. So, that means this will also be at V in. Okay. Now, if this is V in, how much current will flow here? Call this I. This current, let me call this current here I. So, this current is I. So, how much, what can I say about I? I must be then V in by R1, right. Now we will choose R1 such that when V in is around 10 millivolt, I should get full scale deflection in this ammeter. Okay. So, that is what we want. We want as large deflection as possible when the input voltage is applied. Okay. So, we will choose R1 such that when V in is 10 millivolt, ammeter current, okay. Now, the ammeter current is same as I, right. This current which is I is also flowing here I, because no current can go through this. This current is 0. No current can flow through this, through the op amp's input terminal. So, same current I flows here as well as here. Okay. So, we will choose R1 such that when V is 10 milliampere, ammeter current which is given by I is equal to its full scale deflection FSD current, which is how much? 100 milliampere. Okay. So, therefore, we can write this is equal to 100 milliampere. This is how much? This is 10 millivolt, and then I choose the value of R1, and the value of R1 will be 10 by 100, that means this is ohm, this is 0.1 ohm. Okay, this is not a practical number. I mean 0.1 ohm is difficult to achieve. I think my calculation is correct. V is 10 milli and I is 100 milliampere. Okay. So, this is something difficult to realize. I mean, this is difficult to realize an electronic voltmeter with this ammeter which can measure only 10 millivolt. This is difficult to realize. I just will comment this fact. Difficult to realize, this is a very small resistance, difficult to have a standard 0.1 ohm resistance. This happened to be so because I just have taken arbitrary numbers, okay, out of my mind. So, that is why it has happened. Calculation wise this is correct, fine, but after this calculation I realize, okay, this is difficult to achieve, okay, I have to think something else. Okay. So, I will conclude this video, this class here at this point, and so this part of, or this chapter in our course will go like this. We will take more and more examples. Later we will take AC circuits. When we want to measure AC voltage, AC current, we will measure current, we will measure resistance, etc. And we will do it by taking example, numeric examples. We will take a lot of practices, and that will hopefully make our footing on this subject very firm. Thank you.